Live from Soho, New York City, it's Wearable Electronics with Becky Stern.
That's me. Welcome to the show. With me is Phil, Mr. Lady Ada himself.
Hello.
We'll be covering all of the delightful things in wearables.
Yeah, I'll be pressing buttons on this thing,
He'll be tweeting to get us more friends to come and join us.
Yeah, I'll be doing mouse movements, trackpad movements.
He was just talking about how the different keyboards are tough. What's on today's show, Phil?
On today's show, we got a bunch of cool stuff. First thing up is the code.
Dun, dun, dun.
Check light, 10% off, Flora and Wearable section, expires Sunday, 11:59 p.m. Get some deals in wearables and more. Wearable Wednesday.
It's when we show you what's going on this week and debut a new project or video.
Component of the week.
Today we'll be sewing battery holders.
Okay. Tools we love.
We'll be tweezing things today.
And you've got questions, Becky has answers.
Boy, do I. If you have any questions during the show, please post them up in the comments. We will answer them on a future show. If your question is featured on the show, you are entered to win the giveaway that day, and you'll win a fabulous prize. So ask your wearables questions on Twitter. You can ask them in the comments on YouTube, on the blog comments, on Google+. I started watching Game of Thrones. Carrier Raven,
Yeah.
please. My desk is near the window. Just saying.
Oh, so you're starting from the beginning
Yes.
of the series.
Yes.
That's great. One of the things that, speaking of wearables, one of the things that's kind of neat is seeing all the costuming on the Adafruit blog.
Yeah.
And there's a lot of people that are doing costuming specifically for Game of Thrones. In fact, on our site, we had Kalia, and it was someone made their own little dragon that she could ride.
That's really cute.
Yeah, and the dragons are super cute.
Yeah.
Like, wait till you get to the
I
dragon
haven't
part.
seen there are dragons? I didn't know.
Yeah, but no, you know they're dragons. I'm not. There's no spoilers if I'm saying there's dragons.
They
right?
keep holding on the shot of the fossilized dragon eggs. I feel like there has to be dragons.
I feel like this Halloween is going to be fantastic for people who want to do costuming.
Yeah, there's a lot out there going on, and like the series that run really long give you many years for the internet to develop all the tutorials for your favorite characters. But I mean, like I feel like I've blogged like 18 Game of Thrones thrones. Just like I've blogged like every TARDIS scarf, but never watched an episode of Doctor Who.
No, you can participate just with the costuming now. You don't have to know the series. All right. So speaking of, wait, let's pay some bills.
Right. So if you want to get any cool things for your costume from the Adafruit store, you can get 10% off in Flora and Wearables category because the code is Checklight, and we'll find out about that in a second.
Okay. First up, Wearable Wednesday.
What's going on this week?
Yeah.
So Rick Winscott made a pair of Firewalker sneakers. He used Gemma instead of Flora. Remember, the Firewalker sneakers came out before Gemma did, so you can use Gemma for that project if you want. He made a little 3D printed enclosure for the Gemma. It's really cool on his Converse sneakers. And with the LED strip around the bottom and the battery in the tongue of the shoe. He's one of the Adafruit superfans. We saw his project on Twitter. He, of course, was raving about our guide that he followed to build these sneakers, and I think they look fabulous. I can't wait to see a video of them in action.
I had a question for you. So for the folks who are just tuning in, this is the first time they've seen this at Adafruit, because the Firewalker shoes are everywhere. I've seen them on TV, parades, other companies, magazines, you name it. What are they? What exactly are they? What do they do?
They're just a pair of shoes that you've modded with some LED strip, NeoPixel strip, individually addressable LED strip, and a pressure sensor in the heel. We used a piece of Velastat, which is a really durable, flexible, low-cost material that changes resistance when it's pinched. So it's a fairly basic analog sensor, and there's some code on the Adafruit site that Phil B wrote, Paint Your Dragon, to make it look like you're leaving trails of fire when you're walking. So it's like animating the LEDs as you walk. And it's a really nice effect. I'm very constantly impressed with Phil B's NeoPixel Genius.
Yeah.
And the full guide is on the Adafruit Learning System. So lots of people have built them. It's a really good like beginner wearables project if you're already pretty crafty.
And then you can show everybody, which is awesome. So it's a project that's not like, oh, what do you do this weekend? Well, I just sat at home and did electronics, which is fine. This one is, I did electronics. Let me show you what I did, and then you can walk around. It's really cool.
And they're really fun. They're a big hit at Maker Faire and Open Hardware Summit. Like they
Halloween
draw
Parade. It was great. I wore them. Next up, ribbons.
There's a tutorial on Instructables for this product that we carry, the 4-channel silver polyester conductive thread ribbon. It's a super flexible 4-channel conductor, kind of like our 4-channel wire conductor, but it's got conductive thread inside it, and we have a white one and a black one. And the white one you can dye with fabric dye, and so there's a tutorial on Instructables we linked on the blog today for how to dye your white polyester 4-channel conductive thread ribbon cable.
That's handy.
But it's also a handy tutorial just if you want to dye anything polyester.
Yeah.
So it's not like specific to the fact that it has conductive thread. It's more specific to the fact that the ribbon is polyester, and dyeing polyester ribbon requires some constant agitation to get the color like consistent and all that stuff. So there's a link on the blog. The next slide has a picture of that's what the ribbon looks like when you buy it from us.
That's the before, and then on the other side's the after.
Yeah, so you could have it match. Like this would be perfect for connecting to like the Flora GPS, which requires 4 connections. If you wanted it to be like on a hat and then have the rest of the electronics down inside a jacket or something, you could tether them together with this and have it match your outfit. Or you can stitch it down to the surface of a garment or down the leg of pants or whatever, and have it be the same color.
That's super handy.
Yeah.
All right.
Well, maybe you just want to dye your polyester shirt. Also on the blog is coverage of the Cute Circuit New York Fashion Week show. Cute Circuit, known for their very elaborate LED garments. They do a lot of costuming for famous people. They've recently come out with some ready-to-wear stuff, like an LED T-shirt, which I would maybe like to take apart. And they do these amazing dresses. So all of these garments you're seeing here are being controlled by the models' iPhones that they're holding, or smartphones.
Gotcha.
So the animations are controlled that way
Well,
wirelessly.
welcome to what's going to be commonplace and ordinary very soon, folks.
Yeah, I think so.
Controlling your dress, shoes, clothing, hat, whatever with your phone, and it's going to be lighting up based on how you control it, and then maybe on body sensors, or maybe on how many followers you have, or who knows. Like there's no going back.
Right. Or if you just want a regular, you want to go between venues real stealth-like, you can turn it off. Yeah. Unlike, they make the point in the video about this show that like they used to sew sequins on things to be sparkly, and now you can like decide whether or not to have these sequins on.
Yeah.
Or what to show.
Yeah, you can turn it on or off.
Yeah, so that's pretty cool. Neat skirts, dresses. This is a close-up of the purse. We can go full screen on the purse.
Going full screen.
Whoa. I think this is really cute. This is something I would really want. I don't know about the whole display on the front of my body, but I love this purse.
Yeah, that's pretty elegant because it has a nice pattern and it glows and you can turn it on or off. That's nice. Yeah.
I doubt you'll be able to fit much in it besides the batteries required to drive the purse, but maybe a couple credit cards, a lip gloss.
That's all you need.
Lady
Ada only puts batteries in her purse anyways.
Yeah.
So it's perfect.
They're just like, I just eat them like breath mints.
Yeah.
Who needs breath mints when you have a couple coin cell batteries?
Are you like a Decepticon?
I don't know.
Or an Autobot. They eat energy cubes, I think, don't they? That was a cartoon series, not the Michael Bay series. Okay, next up.
Later on today, just over the way yonder, is the Social Media Week fashion show.
Whoa. And
Leslie's Flora umbrella is going to be in this Social Media Week fashion show.
I think this is the most loved umbrella.
It's so nice. Asher Levine, the Laser Girls with their 3D printed fingernails, and some other familiar names are going to be at this fashion show later tonight. We'll post it up with some pictures.
That's cool.
If you're not going to Social Media Week day today or whatever, then like you don't go. So it's not something that like, I don't know.
Yeah, I think
we would send you to, but we'll show you pictures of afterwards.
Social Media Week, the good news, it sounds like everything's going to be posted online. Right? I mean, like, what are they going to do? Like, is it a private event? Like, no, all there is going to be coverage.
Yeah, right. So everybody. I look forward to retweeting it later.
Yeah, this is like the one time.
Do we want to now take this opportunity to mention that Adafruit and me were both nominated for a Shorty Award?
We could do that.
For social media?
Yeah, there's a bitter competition now. So I guess we got to put this up on the site. Either Becky Stern from Adafruit or Adafruit from Adafruit are both nominated for a Shorty Award for
being excellent at social media.
Yeah, and video content and all that stuff.
Yeah. So. Well, but here's the thing. Adafruit gets to take credit for my video content. I get to take credit for my Instagrams, but then Adafruit retweets all my Instagrams.
That's right.
So I accept, but doesn't retweet the Instagrams of my dog. So what am I really, like, what's the differentiation here? I think if you look at the Venn diagram, it might just be like the dog.
I can only vote once, so I really don't want to. I don't know what I'm going to do, actually. I don't know.
We were nominated, but only by the review board, so there's also crowd nominations. So if you still need to nominate us both.
Yeah.
Again.
I think it's an excellent time for anyone involved with Adafruit. I don't know.
I told Phil, I was like, okay, so all those times that I remember to bring my phone on my way to and from the bathroom, which is all the way across the factory, I have to walk through Fab to get to the bathroom. Yeah. All of those times I remembered to bring my phone so that I could Instagram some circuit boards on my way to or from the bathroom. It's really paying off.
Yeah. It worked out. See, it worked out for you. Never leave home without your phone. Okay.
Oh, that brings us to today's project. Can you guys guess what this is? Something we took apart.
Yeah, I like the teardown videos that you and Lady 8 are doing because there is nobody on this planet right now that can open up electronics and just go through everything, how it's made, why they made that decision, why they probably use this circuit board or this part or this thing. And then you can go out and buy this thing if you wanted to and take it apart and follow along, or you'd have better understanding on how the stuff on the inside works.
Or so if you were like thinking of building your own like wearables company, you can like look at the decisions. Like, often these new weird things that are coming out are all funny shape, all by startups. Well, not all, but some. Like this is the Reebok. We'll talk about it later. They like hired a. It's like there's some other logo on the box. Like these startup companies are developing these really weird designs, and it's really interesting to see. It's very like fertile environment for trying new manufacturing techniques and really interesting design decisions. We're really kind of on the the edge of like these new weird devices that aren't the same shape and size as cell phones, but have a lot of the same parts in them.
And what's cool is most of the things, like Adafruit has a component in that's used in those teardowns. So it's like, oh, they use that accelerometer. We use that one too. Like, or oh no, we're actually using a newer version because like this came out and they're probably manufacturing. So
right, it's interesting. So we have a video. We're going to take apart the Reebok Check Light, which you will learn all about in the video.
Roll the film.
Welcome to another Adafruit Wearables Teardown. Today we're tackling the Reebok Check Light. It's a sports activity impact indicator for athletes playing football, hockey, and other sports with risk of head injury. The Check Light is flexible and worn inside a slim-fitting skull cap. The indicator lights at the back of the neck light up in reaction to the severity of impact. To expose the flexible PCB, we cut away the molded plastic enclosure. Let's see what Lady Ada has to say about the engineering behind this interesting design.
Okay, so now let's look at this circuit under the microscope. So yeah, here's that little battery, and you can see it says 0.3 watt hour, a little LiPo, and looks like there's a little protection cell as well. And this is rather nice. It's a micro USB jack, and it's got this plastic surround that protects it and keeps it nice and solid from flexing the Flex PCB, which is what's on the back here. Flex PCB is very delicate, so you don't want to rip it by accident. It's very easy to rip. The battery goes in here, and it goes into a little chip that's marked LCVV. We looked this chip up, and this is a part from Linear Tech. This is a dual battery charger and buck converter, so it's a 2-in-1. You get double your money for this little chip. This takes the micro USB power, the 5-volt in, and charges this little LiPo battery. And at the same time, it also acts as a buck converter. And that's a little additional cost to have a buck converter take the 3 to 4 volts from the LiPo battery and bring it down to maybe 2.5 volts or something. But it gets you just a little bit more juice out of that battery. You'll probably get maybe 20-30% more power. There's a bunch of little LEDs here, indicators for when you've had too many strikes, or if the battery's charging, or if the battery's low. The microcontroller here is for microchip. You can see the little microchip logo up there, and this is a 24F64 series, so 64K of flash probably. It's reading the sensor input, measuring how much acceleration or gyroscopic motion, and then lighting the LED. So a simple microcontroller. You don't have to go crazy with like a big ARM core, but you do want to have a little bit more processing power than like a 8-bit PIC or something. And then up here you see that the 5-pin ICSP connector. This is the classic 5-pin connector for programming the microcontroller. Also, possibly you could use this to read the EEPROM data, which is where the log data is stored. There's no separate EEPROM here. They're using the EEPROM on the chip. Save a little bit of money, save a little bit of space. Okay, so then we can move down to the buttons. And this is the on-off button. And the on and off buttons are capacitive buttons, which I thought was very interesting. You can see if you flip it over, there's that mesh that forms the electrode capacitive touch. They don't use a separate capacitive touch sensor chip. They actually just use the microcontroller. It's very easy to use analog input of any microcontroller as a basic capacitive touch sensor. I'm not exactly sure why they went with capacitive touch instead of a mechanical tactile. It could be for cost, reduces the cost a little bit. It could be for simplicity. Don't have another component that could possibly tear off of the FPC. Probably a choice that they tried a couple different versions and they decided to go with this. Nice thing about this is you don't have anything sticking out that could possibly irritate your head. You just have the flex PCB that acts as the button itself. So moving on down, this is the part that has all the sensors on it that actually do the, how much have you twisted, how much have you been hit. And this is on a flex PCB, but what's nice is they put stiffener. So you see that this actually doesn't flex so much. It's actually more like a very thin PCB. That gives the sensors a good substrate so that they don't tear off by accident. This is the AGD8, so if that sounds familiar, pretty much every wearable that we've seen that has motion sensing uses a gyro. That's the AGD series. That's from ST, the L3GD 4200 or 20 series. This is actually the older 4200, which makes me think that this was actually designed maybe a year or two ago, and they went into manufacture and they decided not to go with the newer version, the 20. 20 is a little bit better in some respects, but probably didn't matter for their design. And if they did a lot of testing with the old version of this gyro, stick with it. Then over here we have an accelerometer, and it's super small. It says 3EK. Now we know that it has a gyroscope and accelerometer, and since we looked through every other chip, this has to be the accelerometer. But it's not easy to figure out exactly what chip that is. And so to figure that out, we actually got our calipers and we measured it. And it's a 2 millimeter by 2 millimeter triple axis accelerometer. And there's not that many 2 millimeter by 2 millimeter triple axis accelerometer. That's really, really small. So we looked up what available 2 by 2 millimeter accelerometers there were, and we found that this is actually a BMA 250. This is a Bosch semiconductor. Bosch, known for sensors of all sorts. They make really good quality accelerometers. There's even Arduino code for these sensors, so theoretically you could actually build this whole project with an Arduino using existing libraries. One other thing that I noticed while taking this apart is there's this black goop around here. And what that is epoxy that they use to keep the chips in place. They really wanted to make this a flexible circuit, so the trade-off is that they added a step where they put epoxy around each chip that adds for stability, and also maybe adds a little bit of humidity resistance. So yeah, this circuit is all I2C or SPI chips that then you can see the traces go all the way back down here to the main processor. And because it's digital, it's okay that they're going, 6 inches, maybe 8 inches down this flex PCB. So all very familiar parts, but put together to make a really cool little sensor. Put this on, stay safe. Wow, this is teeny. Okay.
For this and many other teardowns, we use the Adafruit USB microscope and 6-piece precision screwdriver set. What wearable tech should we tear down next? Post your suggestions in the comments, and I'll see you next time.
All right, fantastic video. That was great.
It's a super cool thing.
Yeah.
I love that flexible PCB.
Yeah.
Really interesting.
Neat design decisions they made, and where they had to put this material to maybe keep the water out, or maybe make it more durable. Cool stuff.
Yeah, and even the molded plastic piece where it transitions from super flexible to not flexible at all. There's some interesting strain relief molded plastic going on there. The way they put as many components at the back of the neck as possible, and just the sensors where they wanted them really up against your head to reduce the likelihood of the device actually hurting your head. The placement of the buttons and everything.
Yeah.
It's
why they did the buttons a certain way. Cool
it's
stuff.
an interesting device. It's a very limited application, right? It's at the back of your neck, so you're not supposed to really look at it. It's definitely for your coach or other players. So it's for team sports. It's for sports with coaches. It's for boxing when you have a trainer. It's for this time when human error is likely, in a football game where you see a tackle happen. Not that I know that much about sports, but then the coach has to make a decision about whether to put you back in the game or not, based on how hard they saw you get hit, or maybe didn't see you get hit, or you're the player is no, I'm fine, and the coach is suspicious. This is just an extra tool in the box for deciding whether or not to send the player to the medic before returning the player to the game.
The player will be all, "Coach, put me in for the slam dunk touchdown," and the coach will be like, "You hit your head too many times. Sorry, kid. Hit the showers or something."
Right, and I think that in the long run helps football teams and stuff. Navigate. I mean, not only is it good for the players, but lawsuits and stuff about coach put me back in when I had a concussion, or coach put me back in when I had whiplash.
Yeah.
It helps liability, and we're seeing these weird innovative wearables coming out of athletic companies. I think because there's a lot of money in pro sports.
Yeah.
And then we're going to see it trickle down. It's interesting because there's wearables tech happening in the military too, but you're not seeing it trickle out as fast as the sports stuff right now.
Yeah, the sports stuff, because there's brands like Reebok behind it, and things seem to be accelerating. Younger kids are getting ready to go or try to go off to the pros, right away. So you're seeing that equipment kind of get in the hands, and plus it looks cool.
It does look cool. Yeah. It's neat, and that flexible PCB is so cool. Like,
it is cool.
Yeah, really neat device.
Next up, we have component of the week.
Speaking of components, I'm going to show you a cool component today. It's this sewable battery holder. So, and we just haven't talked about this before.
So it's a battery holder that can be sewn into things.
Yeah, and so it's designed actually to be surface mount onto a circuit board. So like you can see these little tabs at the positive and negative terminal. They're designed to fit flush on a board. I bet this could go in the pick and place pretty easily and set down on a circuit board and then soldered on surface mount style. However, you see that little hole in the pad? That's so that like solder can bubble up from underneath. You can also sew through it, so it's very convenient.
Yeah, when you're all done, put a battery in it.
Yeah, they put a battery in it. I have, if you want to go to the overhead, I have one sewn onto a little circuit over here.
Yeah. Go to the overhead.
So it's perfect for small LED applications where you don't want to have any microcontroller. You just sew it on with conductive thread. It fits nice and flat onto the surface. Small, the battery's removable, but it's not going to fall out. And then all this circuit does is light up the LEDs. But yeah, so you can sew this battery holder. It comes in our beginner LED sewing kit.
Yeah.
So that you can make this circuit right here. You can make some firefly embroidery or some, prom shoe clips or an LED brooch or a light up Star Wars Jawa doll.
That's what I'm going to be making. All of those combined into one project. Me and Jawa are going to the prom.
Prom shoe clips.
Yeah.
With frogs.
Yeah. Little eyes light up.
Okay. Yeah, so.
And then you got a close-up of all this.
Oh, right, here it is in the GPS. So it's not powering the GPS, it's keeping the GPS's fixed. Yeah. We recommend this in our sewable GPS project so that you can, when it boots up, it kind of keeps an idea of where it is in the world the last time, so it can acquire a location fix faster.
Okay. And next up, we're just going to do tools we love.
Tools that love to stab us. No. Not today, tweezers.
Yeah.
You're not going to get me. Today, the tool we love is tweezers. And we have two kinds of these precision ESD safe tweezers in the store. They're great for using on electronics components because they're not going to store any static electricity and shock your chips. They're really good for precision movement and placement of all kinds of things in electronics and craft world. Like sometimes I use it to get a thread unstuck inside my sewing machine.
Yeah.
Or to thread the serger. These curved guys are so great. You just reach in there and there's 8 threads on the serger. These, however, as you can see, they're pointy. They are not the types of tweezers you would use to pluck your eyebrows.
Have you tried? Are you speaking from experience?
Sure.
So these are okay for eyebrows?
No. Neither of them. Okay. None of them are okay for eyebrows.
Neither one
They're
of these.
pointy. You see how you can't put eyebrow tweezers have like a flat chisel tip so that you have like a plane of pinching,
Yeah.
These are just for picking up and moving around
just
three-dimensional
chips.
objects.
Okay.
Yeah, chips and crafts and
okay.
sewing machines.
All right. Well, those are available in the store.
That's what we're giving away later today is one of each of these. And if you would like them, if you didn't ask a question, then you can get 10% off these tweezers in the store. Everything in the Flora and Wearables category, 10% off with code CHECKLIGHT because we just took apart the Reebok CHECKLIGHT.
Oh, that's why it's CHECKLIGHT. Now I understand. You just tell me to do codes. I'm like, I don't know, whatever.
I don't know what that thing's called.
Okay. Next up, question and answers. You have questions, Becky has answers.
Epic question day today.
First one, what are good techniques to prevent or cover up sharp edges of components and connectors? Round circuit boards and conductor thread are a great start, of course. Printing oval project boxes might help. Covering it covering it in Sucre or polymorph when it's finished is another approach. But seriously, whoever finishes a project, those are asterisks, not quotes. And then the other one, and you could do both these in a row. What are the main causes of failure seen in wearables, and how can we build more robust projects?
Okay, so it sounds like you answered your first question.
Yeah.
Right? Like design round circuit boards or like cut off the corners of the circuit board. If you're stuck with like our perma-protos have curved edges too, but if you're stuck with a pointy circuit board you got somewhere else, you could cut off the corners. Yeah. You can put a little bit of Sugru on the corners. You can put a little bit of fiberfill stuffing and sew it in around the corners to make sure it doesn't stab you. But wires are okay and wire connectors are fine. Like connector thread is nice. It's all about the application. And you're right. Many people don't actually like finish projects, or if they do, they'll work for, like if you're there's this syndrome I see it happen. people finish projects just in time for the event that they made it for, right? Like just in time,
Yeah.
because the project will fill up the available space you give it. And then after that, you don't have the impetus to work on it anymore. So it is as done as it's going to be, even if you had to kludge a few things together. But often wearables need repair. So you wouldn't want to like seal everything all up so that you can never get at it, because then you can't inspect it for wear or fix it if it's broken. But yeah, I don't know, just use round circuit boards. If you can't, put it in a place where it's not going to stab you. And then
Next up,
the question was about, what was the second question?
how do most projects fail and not work out?
Wearables projects, I mean, when I've talked to people who work in development of wearables stuff commercially, they talk about washing. They do a lot of washing tests to see how long things last in the wash, based on like corrosion, physical wear, so things breaking or pulling, and abuse. So somebody recently, if you check in the the wearables board on the Adafruit forum, someone was just asking about like making the Firewalker sneakers LED strip, like how to fix the fact that like it's bending laterally at the toe of the shoe, and like what to do to make sure my shoes never break. Well, guess what? The shoes they're gonna break eventually. Shoes don't last forever by themselves. So you accommodate for the limitations you're given. You don't abuse this. We've abused ours. Don't go skateboarding in your Firewalker sneakers.
I've done that.
Like more than twice.
I've done that.
Yeah, the third time you broke them. Yeah. So like try to mitigate instead of heavy-handedly like overhaul.
Can't plan for
things.
everything, so maybe plan to repair.
Right,
Yeah.
plan to
Yeah.
repair. And then
So,
you have
I do.
thoughts on this too.
So from answering all incoming emails to Adafruit for 4 years, now I don't have to answer as many, but I can tell you the number one thing is folks, they just want to do their project and they don't follow the instructions step by step. They'll skip to the end and they're like, I'll just look at the photo at the end. So the Adafruit learning system has very specific steps, and if they're numbered, follow that order. And it's okay if you don't do that. Just realize that you are going to break stuff. It's going to cost you money, and that's a good lesson to learn. It has to cost you like $100 once or 4 hours of your time for you to say, you know what, I'm really going to like read the instructions next time.
Yeah, because I mean, I can
to
tell
happen.
you right now, read the whole guide before you check out at the cart, and then read the whole guide again before you start, and then read the guide as you go when you're building your project. But you won't listen to me until you break something that
There has to be consequences to your actions.
like you have to internalize it in order for you to actually like be like, oh wait, I should read this whole thing before get into the habit. So read the instructions.
Next up, this one is from Chris. I'm new to all this. What does one do about lining in clothing? Does some added lining cover up the guts while others don't? Is this safe?
Often we'll use lining. So like your jacket that we turned into the GPS jacket, that has the battery wire like routed through the lining of the coat down to the pocket, which actually keeps it a little bit safer. So that wire's not going to get snagged when you put your jacket on and off. It's nice and safe in there. But also then you can't see if there's a wire connection coming loose or shorting. So that's a thing. The sparkle skirt has the circuit is actually constructed onto the lining, and when you're wearing it, the conductor threads are touching your legs, and your legs are actually like preventing the front and the back of the fabric from touching. But when we hang it on a hanger, we have to put another piece of fabric inside. And one time someone was making a very ruffly sparkle skirt, and they were having problems with the threads like overlapping each other, and we recommended they add another piece of lining that lines behind. So linings are great. You can put linings in stuff that don't have linings. You can build circuits into linings. I love clothes with linings.
Okay. And then we're going to do, this is going to be the last question. We'll save the other two for next week.
Okay, but then everyone who was in the bucket was...
Oh, you want to speed through these?
Yeah, I'm worried about that because they're all in the giveaway bucket.
Okay,
let's
speed through these.
We'll speed through.
Let's go. 2 questions. Have you ever taken any wearables with GSA security? And instead of snaps, can you use magnets on the pads? I can answer the first one. Yes, I have. I've taken almost everything here at Adafruit through security. I've never had any problems. That doesn't mean that you won't. I usually fly out of JFK and SFO. I always have the tutorial with me and a business card. And the only time that I really had to explain to something is when someone wanted like a copy of Make that I had with me. And then for the other one, for snaps and stuff, you have a demo.
You can look at the overhead here. I have little bits in my hand. So magnets, you can't solder to them or they will become demagnetized. That's kind of how magnets work. magnets are made by heating up the metal, applying a magnetic field, and then letting them cool down inside the magnetic field. So when you heat it back up and there's no magnetic field, it's going to lose its magnetism. These magnets on little bits, they function to hold these little gold-colored connectors together. They don't actually make the electrical connection. The magnets are glued in cold later after the circuit's been soldered, and you can see that they hold these little connectors together. So you can't solder magnets to Flora. Sorry, buddy.
Okay. Next up. Zoom question. Any thoughts on the feasibility of building a bone conductor transducers into helmets, bicycles, and motorcycles? My concerns are avoid reducing production capability, sound transmission quality and comfort, any mounting construction ideas. Thanks, Paul.
I am not a bicycle or motorcycle helmet design expert at all. And I do think that sticking those bone transducers inside the helmet, it's a pretty big chunk of metal. If you land on it, that thing is going to get pushed into your skull.
I don't even know.
So when we took apart the Synapse bone conduction hat, and it has the two transducers back here, they actually, and then you see footage of my friend riding his bicycle to work, wearing the hat with the GoPro camera. The transducers are not actually under the helmet, they're below it. They're like down here, and then the helmet goes up here. So if he were to fall off his bike, the bone transducer would not be slammed into his skull, so that's hard. He also said that after like his 20-minute commute, they started to agitate your head, and that's just like, I don't know, there's that guy that sees with uses color, he's colorblind and he has it on all the time, but your mileage may vary. I found it uncomfortable after a while, so I would be really hesitant to stick them up inside a helmet at all, because it might make it safe at all.
Yeah, also look and what's available commercially. If there isn't a commercial version of this available,
they're probably safe.
Well, it might not even be safe, it just might not work that well.
Yeah.
So
they're kind of uncomfortable. For short periods of time, though, they're pretty cool, like a bike commute.
Okay, last question, then we're going to do a giveaway. Becky, I have a question and a tip. The question is, can you use a capacitive sense library on an actual wearable item, or will the wearer's body interfere with the sensor?
We just saw it in the Reebok check light. They use capacitive touch buttons, and they do say in the FAQ that moisture can affect the sensitivity of the buttons. So that's a drawback. I found that the calibration, if you're not earth grounded, the calibration can be an issue with your own DIY project. So that like the button readings will not always be the same. You can accommodate for that with like a potentiometer knob or like some self-regulating attenuation on the calibration. But yeah, it's kind of an issue, but try it. And,
okay.
Yeah,
and this is a tip. I've had decent success using a single beater. I picked up some spares from a thrift shop from an electric mixer, chucked in an electric drill to mix up castable rubbers. Just don't mix too fast and minimize introduction of air bubbles in the mix.
But Ray, how will I work out my arms if I can't stir the moldable rubber with just my arms?
Yeah, is that why one of your arms is gigantic and the one's small?
I actually have like really super Popeye forearms. I don't know if you can see that.
Very
yeah,
strong.
Look at how much bigger my right forearm is than my left
You're
forearm.
very strong. You're like an arm wrestler.
Just my forearms.
All right.
That's it.
Okay. Well, everyone who asked a question is
Those are really good questions.
Yeah. Which pair of tweezers are you giving away?
Both. You're giving one of each.
Oh. So I'm just going to show this. You're going to get this one, and then you're going to get this one. Look at you. Whoever you are is future winner.
Future winner. Okay. Who is the future? Who is the actual winner? Let's see. Do. Oh, it's Becky. It's our inquisitive blog writer.
You won! Oh, not you.
Not me. Other Becky.
Yeah.
Becky, who asked about sharp edges, and she asked a bunch of questions. And what are the main reasons of failure? The first question we asked. Congratulations. You can email support@adafruit.com to claim your prize, and I'll also send you an email since you commented on the blog. If you would like to enter the giveaway, all you have to do is ask me a cool question about wearables. What do you want to know? What are you curious about? A question about any of our videos or any of our wearables parts?
Yeah. And thank you everyone who's posting up in the comments on YouTube. Those are good questions, and we add those to the question bank.
Yep.
So make sure you tune in.
So either next week or the week after. Sometimes it takes me 2 weeks to get to your questions because there's a lot of them, but if it's a good question, it definitely gets entered in the mix. And remember to buy things. Use code CHECKLIGHT to get 10% off anything in the Flora and Wearables category all day today. If you're watching the show and tell or the Ask an Engineer later, you can only use one code.
That's right. There'll be another code later tonight.
Yeah, so if you don't like the code CHECKLIGHT,
there'll be another one.
There'll be another one later today, but you're only going to get 10% off no matter what. So.
Yeah, I'm going to check dark. I don't know.
Check dark. That's not a Reebok product.
Oh, all right.
Yet.
Yeah.
I have a feeling, based on some of the things Lady Ada described, I have a feeling they're going to come out with a new version that like pairs with an app on your phone. I think they're going to add a Bluetooth module next because that would be the logical.
Maybe they'll look at
Checklight Pro.
Maybe they'll use a Bluefruit product. Who knows? Who knows?
Cool. Anyway, thanks so much for watching and joining us today. We'll be back here same time next week.
Yep.
More wearables.
Okay.
Batteries video next week. Don't miss it. It's going to be really cool.
All right. And we'll see everybody tonight at Show and Tell 7:30. and Ask an Engineer at 8 p.m.
There's a new wearables guy. He's gonna try to join the show and tell today. I talked to him over email. He has some really cool. The guy who made Zacky's, the hand, the gloves with the turn signals in them.
Oh, cool.
I taught him how to join the show and tell. So hopefully he'll join later, either today or next week.
Okay.
And show off some of his cool wearable LED stuff.
We'll see you all back here in 5 hours. Bye-bye.
Take care.